A frog sitting at the point 1, 2 begins a sequence of jumps where each jump is parallel to one of the coordinate axes and has length 1. And the direction of each jump, which is up, down, right, or left, is chosen independently at random. The sequence ends when the frog reaches the side of the square with vertices 0, 0, 0, 4, 4, 0, 4, 4, and 4, 0. What's the probability that the sequence of jumps ends on a vertical side of the square? Okay, so the first thing we do is we kind of look and see what they mean when they say vertical side of the square. And basically what they're saying is, what's the probability that the frog ends up on either this side or this side of the 4x4 square which I've drawn over here. And he's going to start here. But at this point, it seems a little bit unclear about how we solve this problem. So let's do an easier problem where the frog starts on 2, 2. Then obviously the probability would be 1/2, right? Because the frog is exactly in the middle of the circle. So the probability of, excuse me, the square. So the probability of going to any of the 4 sides is the same. So on 2, 2, the probability would be 1/2. Let's try it with 1, 3, because it's also on a diagonal of a square. It turns out the answer, if the frog starts on 1, 3, is also 1/2. And the reason is because, well, the probability that the frog ends up here is equal to the probability that the frog goes here. The probability that the frog goes here is equal to the probability the frog goes here. The probability that the frog goes here is equal to the probability that the frog goes here, and so on and so forth. The probability that he goes there is equal to the probability that he goes here, and the probability that he goes there is equal to the probability that he goes here. All right, so the probability that he ends on a point on the vertical side is equal to the probability that he goes to a point on a corresponding horizontal side. So if the frog starts on 1, 3, your answer is 1/2. And similarly, if the frog started on the point 1, 1, your answer would also be 1/2. Okay, with that being said, let's start the frog on the point 1, 2. Okay, so the probability that the frog goes to, well, the frog can go to any of the 4 vertices adjacent, that is this one, this one, this one, and this one. The probability that he reaches each of them is 1/2. So now what can we say? The probability that he goes to 1, 3 is 1/2, 1/4, excuse me. So the probability that he goes to 1, 3 and then ends up on a vertical side is 1/4 that he gets there times 1/2 that he makes it to a vertical side after that. The probability that he goes to 2, 2 is 1/4. And the probability that he goes to a vertical side from 2, 2 is 1/2. So the probability that he goes to 2, 2 and then ends up on a vertical side is 1/4 times 1/2. The probability that he goes to 1, 1 is 1/4. And the probability that he goes from 1, 1 to a vertical side is 1/2. So the probability that he gets to 1, 1 and then reaches a vertical side is 1/4 times 1/2. Finally, the probability that he goes to 0, 2 is 1/4, in which case he's already on a vertical side, so he wins for sure. So the probability there is just 1/4 that he'll succeed. And finally, our answer is the sum of these 4 quantities, which turns out to be 5/8. And we are done. So thanks for watching, and I will see you next time.